have a ribbon to part 2.
I accidentally opened iTunes instead of Audacity, and I don't know how I did that.
What do you mean? Apple wants to be your one-stop shop, wants to make sure that whenever you need to make some kind of audio podcast, you think of Apple computers.
Okay.
That's how it goes down. Have you pre-ordered your iPhone 10 yet?
No, I have a bare bones iPhone 8.
So you did get an iPhone 8.
Mm-hmm.
That's for poor people.
Academic.
Oh. No. I stole that from the latest Harmontown podcast, where he's like, "Oh, have you heard about the iPhone? The new iPhone's coming out. Are you gonna buy one of those?" And he's like, "Yeah, I'm gonna have to get the iPhone 10. You're not gonna get the iPhone 8? Of course not. That's for poor people. I'm not getting a Pixel 2."
So I had this discussion with myself of I really want the iPhone 10, but why do I want the iPhone 10? I want it because of all of the lighting modes. But wait, that's just software and 2 lens, and I really should replace my camera, my like actual camera, because this has more pixels than my T3i.
Mm-hmm.
And so would I rather get the cheapest iPhone 8 or get an iPhone 10 and not be able to buy a new camera when Black Friday sales are among us? So
do I love my camera.
I know.
It's a pretty great camera.
I want a different camera than your camera. I'm sorry.
It's fine. Whatever. Just be wrong. It's fine. I'm going to say hi. I forgot to say hi to a bunch of people. Hey, to Adam Synergy, Ben Kalo, Bill K, Bort Klinkar, Brian Stab, Chris Bamford, Dane Kovu, every time. I know. Galaxia, Guido Bieber, Hugo Burnham, James Haney, John Suffield, Quiddle Libet, Larry Beckham, Matt Minter, Michael Collins, Nancy Graziano, Nichols of the Yard, Ocean McIntyre, Paul Taylor, Rinstro, Rick Schwartz, Sammy Kempinen, which sounds Finnish to me, Steve Heistend, Susan Murph, Tom Van Scotter, Tony Raggett, Yamagashi-san, and Zapfan. Hey, everybody. My camera's obsolete? What? It's not. I have the new...
Wait, which camera?
I've got the Panasonic, the Lumix
Yeah.
GH5.
Yeah, that's not obsolete.
I used to have a
Canon
5D Mark II, and that is definitely obsolete. Don't like it.
It's not as obsolete as my T3i.
No.
You went you're like on your 4th camera after we bought matching cameras.
Third, yeah.
Okay.
Third. I got a used 5D Mark II, and then I got this guy, and it's a really good camera. 4K, 60 frames a second, 180 frames a second, super slow-mo. It's the way. All right, let us begin because we've got to book out. I've got to head out in 38 minutes. So
Okay.
I'm going to go for lunch with the parents. Yeah. So I'm going to press record whenever you're ready to press record.
I am pressing record. Hey, Chad. Again.
Hey, Chad. Here we go. I said your name, Quad Libbet. That's.
Sorry, Chad.
Astronomy Cast. Oh, actually, Chad will hate that. Let me do this one more time. Astronomy Cast, episode 462, Modeling the Weather. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. My name is Fraser Cain. I'm the publisher of Universe Today. With me is Dr. Pamela Gay, the Director of Technology and Citizen Science at the Astronomical Society of the Pacific, and the Director of CosmoQuest. Hey, Pamela, how's it going?
It's going well. How's it going with you, Fraser?
Really well. We are about to do the second episode on what's happening with the weather. Before we do, how is Image Detectives going?
It's going well. We need more people doing it though, because we have 1.5 million photos. So
A
please
lot of photos.
go. Yes,
Those
yes.
astronauts were super busy.
Yes, and they've been busy for a long time. So if you want to see some truly stunning photos, all of which you can download and turn into your screen backdrops to your heart's delight, go to cosmoquest.org/image detective and help us figure out what the heck the astronauts were taking pretty pictures of. Um, and you will help us be able to use this science to figure out how our planet is changing as it gets impacted by the weather.
And help science.
And the faster we get more images done, we're currently working on building a catalog that will allow you to look things up in much the same way that you'd look up to find, is there a hotel near this place? We're now going to have it, is there an astronaut photo near this place? And instead of filtering by pools, you can filter by, did anyone identify any lakes? Did anyone identify any volcanoes? And we just need to have enough things in the software to like thoroughly test the software. And we have, I want to say it's 330 images that have all been viewed by 15 people and thousands of images that have all been viewed by like a person. So go in, don't skip too many images that you have half a chance of finding. And go through, and our goal is each image has its center identified by 6 people, or we give it to up to 15 people who don't find the center. And once something has been viewed by 15 people, none of whom have been able to identify the center, or fewer than 6 of whom have been able to identify the center, we put it to the end of the list. And things will come back until we find the centers of everything or determine centers can't be found.
So I've got one quick thing. I'm going to do a more formal announcement, but I want to give the Astronomy Cast listeners a super sneak preview, advanced knowledge opportunity to make your reservation, which is that, as you may know, Dr. Paul Matsutter and I are going to be going to Iceland in February. That filled up in moments. So now we've got another trip planned. We're going to be going to the Caribbean for a cruise to see the stars and the ruins and also rockets. So we're going to be going in late September. We're going to be going to starting at Cape Canaveral. Of course, we're going to go see Kennedy Space Center, and then we're going to do observing every night. We're going to do a bunch of live shows. We're going to go see the Mayan ruins and some other places. And so you can check out information on that at astrotouring.com. And we've got, as you know, a set number of slots, and when they're gone, they're gone. So September 2018, if you're interested in going on a vacation from the 20th to the 29th, come with Paul and I. We'll have a lot of fun. So and I will do a more formal advertisement in the show, but this is for the folks who are interested. Go to astrotouring.com, you just put down a $25 deposit and you're in. So, and then figure out the details later. All right, let's get on with this show. Have you noticed that weather forecasting has gotten much better in the last few years thanks to weather satellites, weather stations, and better forecasting techniques? How do scientists predict the weather with any kind of accuracy, days or even weeks in the future? Pamela, how does this work?
They use a lot of math and big computers and do things very, very carefully.
Right. So we talked last week about the weather satellites. I mean, that's really only a small portion of the weather monitoring system. So before we get into the way they do their forecasts and their models, let's just talk briefly about what they've got that is capturing the data planet-wide.
So we're looking at a variety of different things that are gathered from weather stations on the planet, gathered from aircraft that are, in the case of hurricanes and other dramatic atmospheric events, going out and taking measurements. And then, of course, we have our suites of satellites in geostationary orbit, as well as the polar orbiting satellites. And the kinds of data that are getting gathered include how is the surface barometric pressure changing? How is the column density of the toposphere changing? This is measuring pressures higher up effectively. What is the temperature structure of the ground, of the water, of the atmosphere? What is the wind? What is the cloud cover? And by taking all of these different things into effect, we've started building more and more complicated computer models that take into effect more and more data at higher and higher resolutions to build all of our different models.
And so you've got all of this data that's pouring in that's been, in some cases they've got really good regular data that's been gathered for hundreds of years in some cases, depending on, the kinds of weather stations that were recording some of this information. It's actually really amazing. Even I know that ship captains, they're pouring through old data from ship captains back in the 1700s, 1800s, and they would keep track. The direction the wind is blowing, the weather that we're seeing when they're crossing the Pacific Ocean in exploration. So there's all this great data that's being like pulled together and fed into computers, and then what are the meteorologists, what's the term, weather forecast meteorologists,
Meteorologists.
yeah, the weather
So
forecasters, the researchers doing with it?
it actually has been something that people have been really doing as what are called citizen scientists, which we've talked about just a few times on this show.
Yeah.
They started during the American Revolutionary War when the United States seceded from the British Empire. And it was our founding fathers who realized that it was national security in some ways to be able to predict the weather. And so they asked farmers to go out and look to the horizon and report, what does sunrise look like? What does sunset look like? What is the cloud cover? And then to measure the temperature, to measure the barometric pressure. These are all things you can do with essentially no technology tools, just little pressure gauges and oil or mercury or alcohol thermometers. And all of this data has been getting collected continually. There are people still doing this, still part of the original project that it was Thomas Jefferson who formalized. And the data is going to the Smithsonian. And that was where it started. And people started in trying to figure out, okay, what can we do with this temperature and barometric pressure data and looking at the sky? And it was realized if we have a sudden drop in barometric pressure, that actually means that clouds are going to form, that rain is going to fall out of the sky and make you very wet. Whereas if you see the barometric pressure going up, that pressure increase is going to push away the clouds and actually leave you with a bright sunny day. So this interplay started to give us a way to say, if this, then that. But it was a very simplistic if this, then that, because it was impossible to know that there was actually this massive low pressure front banding across the entire United States that was headed your way with massive cold temperatures on the other side with tornadoes that would be generated.
Right.
To get to that point, we needed like the telegraph machine. And so as technology has advanced, as the speed of our ability to report data has advanced, we've been able to get more and more advanced weather forecasting.
And so, you've got all this data. What do the researchers do with it to get in, to understand the patterns of what you mean? You just mentioned, anyone can do this. You get a barometer, which, by the way, get a weather
Everyone
station.
Should
Everyone
have
should have a weather
yeah.
station, right? They're so much fun. I did it as a kid too. It was my job every day to track the rainfall, the temperatures, and what the barometer was doing, and we would store it in a little book. And exactly what you're talking about. I don't know where the book went. It's possible the garbage, but I like to think that it was sent to some Canadian data center. But what are the scientists doing with this? How did they learn to be able to model the weather?
It was in the 20th century when people started to realize we can start to use fluid dynamics, we can start to use the detailed science of how gases interact to start to put together numerical weather predictions. This was work that was largely done by a Brit by the name of Lewis Fry Richardson, who wrote a book that was very straightforwardly named Weather Prediction by Numerical Process. And at this point, unfortunately, in the 1920s, we didn't really have computers. And so Richardson kind of imagined following the model that we saw used in astronomy, where they had a whole bunch of women who were performing the work of calculators. And he imagined an entire auditorium filled with human beings who were sitting there, each doing their calculations, passing their paper to the next person who did their calculations. So you essentially had human beings doing parallel processing, but there was no way to do it. And so it wasn't until computers finally started to get built that we saw a whole group of people using the early ENAC computers. And what I love is here you have Clara Dane von Neumann, who is a fairly small human who did amazing software development, and the contradiction between the human and the data capabilities. I love it when powerful brains is contained in little tiny people. So you have the mathematician John van Neumann, you had meteorologist Ragium Fortoft, you had Clara, all working together in the 50s on early computers to start developing software. In that case, it was actually mostly hardware that could do a single calculation. They were programming electronics to take all of this data that humans can't by themselves deal with and build models that were coarse, that treated smaller countries as one grid on the calculation, but that were better than anything we'd previously had.
And one of the great things about having all this data is that you can essentially run a prediction historically to see if what you thought was going to happen did actually happen, right? This sort of regression testing where you can just kind of go again and again to see if how well your model predicts the future. And by how well your model, you start by making your model predict the past, and from there you can then try and have your model predict the future.
And this is actually part of how the different nations decide whether or not to upgrade their data models. Uh, Scientists are always trying to find new ways to remove the assumptions, to remove this is based on brute force rather than on underlying equations out of our software. So as they're trying to figure out hurricane models, as they're trying to figure out storm forecasts, they look at all the historic weather models and they say, if I feed my software everything up to the Sunday before, is it able to figure out what happens 1 day later, 3 days later, 10 days later? We can't really go beyond 10 days. We're still not there. And if the new computer models can consistently perform better than the prior computer models, it's like, okay, everyone update your software. Go from Windows 95 to Windows, I guess it was 3.1 to 95. Don't do the reverse. And this sometimes leads to controversy. This happened earlier this year when there was the question with the U.S. National Weather Service on whether or not they should upgrade their models to new software or not. And what I find interesting as a complete outsider to this field, and I love doing this episode because it gave me a chance to look up and read about all of this different way of looking at our planet instead of other planets. There was controversy because the new models don't always perform better. So the question is, do you want to maximize your model to be better at predicting tornadoes, but not as good at hurricanes? Do you want to maximize it at being able to get rainfall amounts correct, or do you want to maximize it at getting wind speeds correct? And so there's so many different ways of saying this is the best model. What do you prioritize? And so they did make the update, but there's a lot of people who are resolutely like, that wasn't a good choice. And so you quite often see, we're just going to show you all the models, all of them. And so lately with the weather tracks for hurricanes, we've simply been seeing, as consumers of weather content, the meteorologists putting out all of the results from all of the models, and then explaining that this cone we have of prediction for weather tracks is actually based on integrating across all these different models and trying to figure out what is the most likely scenario.
Right, right. And this is where we put meteorologists into a cage match and make them fight to see whose weather model is the most accurate. I believe that's how it works.
Pretty much, pretty
Yeah.
much. It's more their software's doing the cage match.
Right.
And it's a question of whose assumptions were the most accurate assumptions, because unfortunately, we don't have complete data. And so you have to make certain amounts of assumptions.
And this is still, I mean, I feel like, with the modern age, with all of the sensors that are coming online, with all of the satellites that are coming online, these models are becoming really fine, nuanced versions of one another at this point. Like the broad strokes is understood fairly well, and now we're able to do things like, is it going to be rainy here on Vancouver Island in 2 weeks, or is it going to be
Yeah.
partly sunny? Right? That's the level of, I mean, I do find myself starting to make plans around the weather forecasts in ways that I never used to.
And what's amazing about this is it's allowing us to understand more and more as our models get better. It requires us to be better about our data. So we have to take into consideration that cities are heat traps, that as a storm sweeps across the landscape, how it behaves changes, whether or not it's going over that nice, cool cornfield or it's going over a big asphalt, hot, trap the heat and re-radiate it
Right.
pavement.
Well,
And
go ahead. Yeah.
so our models are now telling us we as humans are impacting the models through urban sprawl. And so our models have to take into consideration the fact that that new suburb got built.
Yes. And this is where I think really the technique is really getting finely honed. Is you've got these situations, as you said, you've got these human built structures that are actually changing the weather, the croplands, the heat islands of cities. If it feels like it's hot in the city, it literally is hot in the city. And as soon as you head out into the forest, it's fine. I promise you. And so it's that mixed with, and then we've got this other situation, which are these long-term climate changes that are happening, both natural and human caused.
And are actually mucking up our simulations to a certain degree because the ocean temperatures are dramatically changing. And with these changing ocean currents, as well as we add more and more fresh water into the oceans, as we drop in new icebergs on a regular basis, this is changing the interplay between the ocean and the atmosphere. As we remove forests, it's changing the interplay between the landscape and the atmosphere. And so when we have a model that is focused on, I'm going to predict Europe taking data from these places and I'm going to ignore what's going on in Australia, that might be a mistake because it is a global atmosphere. And what is happening in Australia is related to the Pacific Ocean, is related to what's happening in South America, is related to China, to India. It's all one story. And if your model says, I'm going to take in these inputs, which I consider good enough, but I'm not actually like bothering to calculate with everything because processing time and I want the model to finish someday, um, we get inaccuracies because we can no longer assume the Pacific Ocean works this way, the Atlantic Ocean works this way. There is a hurricane currently barreling towards Ireland as we record this.
Right.
That is not normal.
Right. But, what is in this day of crazy climate weirdness? But so that just causes, just when the scientists thought they had these data models figured out and could tell me whether or not it was going to be rainy or partly cloudy in 2 weeks, now the long-term changes are causing more instabilities, changes in rainfall patterns, changes in temperature both up and down, increased hurricanes, increased tornadoes. And it's those things, those hurricanes, for example, where people are keenly interested in to know if there's going to be a hurricane, where that hurricane is going to hit.
And we used to be pretty accurate at knowing how strong the storms would be. I remember watching Katrina and Rita and all of those hurricanes back in 2005, and our understanding of just how badly the Louisiana coastline, the Texas coastline, we're going to get creamed, it was pretty good. Whereas looking at things this summer, I need to go back and do a one-for-one comparison, but it feels like the storms are suddenly getting much stronger than we predicted. I'm seeing this with Ophelia. Ophelia was never predicted to get Category 2, and then it was a Category 2. It wasn't predicted to stay a Category 2. It stayed a Category 2. And so we're seeing intensification that we haven't seen before. Now, what this could be is we have models that work perfectly well based on a set of assumptions. So this is the problem of you're going up the stairs and all of a sudden one of the stairs is 2 inches taller than your leg anticipated and you fall on your face. We know how stairs work, but because we had an assumption, the model falls on its face. And so we have to figure out which assumptions do we change so that we can still calculate the models and they're accurate for our new normal.
Yeah, and this is why the scientists are saying, say, in terms of global warming, the temperatures are going to rise this amount by this period, while others, based on different models, different assumptions, are saying they're going to rise by a different amount. And really, each year, everyone is looking at how well their model predicted what actually happened. Did the sea ice drop again? Did glacier melt cause? Did the methane vents in the at the northern latitudes cause a problem? I mean, each of these issues is making the job of climate prediction so much tougher.
And volcanoes. Don't forget the volcanoes.
Yeah, absolutely. I mean, just the normal variations. What's happening with the sun? What's happening with the volcanoes? What's happening with, as you say, the heat islands, things like that. It's just it's a very complicated job. I was just going to say, does just really powerful computers make the problem go away?
It doesn't make it go away, but it starts to make it so that fewer assumptions are required so that we can do a finer grid mesh of calculations. Where it starts to get messy is just what all do we have to include? How salty the North Atlantic is actually makes a difference in understanding the currents and understanding the heat capacity. And as these things change, which we're not used to these things changing, it changes our models. And it's important to remember that with climate change, it's not just everyone's going to get warmer. It's actually the weather is going to get more extreme. So everything that we're experiencing this year is completely consistent with the models that scared the bejesus out of me in the early 2000s. And I wish that was a lie. There was like literally a Friday night where I'm like, have you seen these journal article papers?
Right.
And the issue is that as we end up with more energy stored in the ocean at tropic latitudes, you have these storms that spin up much stronger. As we end up with difference in how the jet stream flows and how the tides dissipate that energy in the equatorial regions, we see that the northern and southernmost latitudes actually get colder. So we're going to have more extreme winters in the Canadas of the world.
Right.
And I live right at the crux of all of it, so I'm going to get more tornadoes.
Yeah.
So this is what climate change is. It's a global, on average, increase, which we'll see as a significant warming in equatorial regions, and more extreme weather, which includes more extreme cold during the winters in the northern and southern latitudes.
So once again, I give you a blank check here to fund your weather forecasting. What would you like to see that money spent on?
A think tank with a set of supercomputers dedicated to running models. Imagine if you could get the best meteorologists from around the world working in their own Max Planck Institute kind of place with unlimited computing technology, with that mesh of satellites that we discussed in the last episode, as well as full access to all of the planet's weather stations. I'd want to see those people with the best computer scientists in the world working to advance the models, advance the software, and find ways to get fewer assumptions and more calculations going into how we see into the future.
I'll see what I can do. Thanks, Pamela.
My pleasure.
Stop. Save. And then we've got time for like 9 minutes of questions.
Okay.
462. But don't upload.
I paused Dropbox.
Yeah.
I paused Dropbox.
Good. Oh, so here's a valuable life lesson that I learned about these sharing software. If you use Google Drive and you delete a bunch of files, a bunch of directories that have people sharing files into your directories.
Yes, you delete their stuff too.
You don't.
Oh.
Yeah, and in some cases you don't delete your own stuff, but it goes into this mystery hidden directory that you have to very specifically search for. And so if the amount of Google Drive space that you have left seems like not enough for the amount of files that you think you have, and especially after you've cleaned everything up, there's this weird limbo where your files can go. And so,
there's a way, if you own the file, to make it go away for everybody.
Yes, if you own the file, but in cases if you create the directory, but other people upload stuff into the directory, or if someone creates a directory and then you upload files into that directory, and then you delete the directory because it's in your Google Drive, and but they're still your files. Anyway, limbo. So just keep that in mind. Don't delete directories on Google Drive. Delete files, then delete directories. That's all I'm saying.
Okay.
Yeah. You had dinner with Elon Musk?
Yes, a number of years ago. Back in 2009.
Right.
And he schooled some economists who were at the table.
Oh, really?
Yeah, he just schooled them. A discussion broke out on whether or not you should lease or own a home.
Oh, right. You told me this story.
Yeah. And he was very much, there is no reason to own.
Right.
And the economists were like, blah, 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 ownership. And he was like, no. And just very matter of fact, in a very matter of fact manner, explained in detail that you could not question why he was right. And the economists kept trying to go, blah, 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 blah. They were academics. They did the academic thing. It's a dance. We've all been trained to do it. Elon Musk is not an academic. He is an engineer. And he was just like, no, data. And it was amazing. And I felt bad that I own a house, but I live in the Midwest where situations are slightly different than what they were discussing. And I didn't bring up anything.
Good. Like, instead, you asked him if we were living in a simulation.
No, no. Didn't want to have that discussion.
Um, so Arjo wants to know: is there more energy in the atmosphere this year than usual?
Uh,
I mean, there is. If I sort of understand my understanding of this question right, is that we've got, because of the increased amount of carbon dioxide, that is trapping more energy in the atmosphere.
well, I don't know
Literally
how much. I
every
don't know how
year.
much of it is in the atmosphere versus the ocean.
Right. Okay. So
So,
more energy in the system.
yes,
Yeah.
there's more energy in the
Yeah.
system.
So every year that goes by, there is more because as there is more carbon dioxide in the atmosphere, there is
And
more.
methane and other
Yeah,
things.
there is more energy trapped in both the atmosphere and the ocean and the land. It's all just there.
Right.
The Earth is trapping more energy, and it's a lot. Like, it is thermonuclear weapons worth of energy going over and over and over again.
If you don't want to sleep, read about climate change and ask yourself questions about what is the carbon footprint of space tourism? What is the carbon footprint of Amazon Prime? What is the carbon footprint of wanting fresh oranges in winter? And you will hate everything.
Especially yourself. But
I put more miles on my bike last year than on my car.
so someone that's awesome. You're the best.
I
Someone
live in a very small town.
did the math. Yeah, you're very conducive to cycling. Someone did the math on the BFR actually, and that the big freaking rocket from
Yes.
SpaceX. So they're building this fuel system that's going to operate off of Mars. It's going to use this. I forget the name of it. It's named after the inventor. It's like 100 years old. But you essentially use electricity to pull carbon dioxide out of the atmosphere. You mix it with water to get methane, and then you create and also liquid oxygen, and that you can make this methane rocket fuel from the surface of Mars if you have access to a source of water and solar power or nuclear reactor, right? But you can do the same here on Earth. And so someone did the math, and it turns out that if you use renewable energy to make your methane, then you have a zero carbon footprint for these massive rockets that go off because they are pulling the carbon dioxide out of the atmosphere. They're mixing it with water. They're generating carbon dioxide as the methane is burned, but the total amount is flatlined. And so I wouldn't be surprised if this is the way that's our renewable fuel.
The issue that you have to watch out for on those, yes, renewable fuel, I'll give you. But one of the problems that we've run into before is airplanes, rockets, things that aren't on the surface of the planet will emit greenhouse gases at the levels in the atmosphere where they
Right.
can do the greatest harm.
Right. And so this is the problem, right? Is that they're going to be at higher altitudes injected right into the atmosphere, which is bad.
Ozone in some places, we need it. Ozone in other places, oh, no. Bad.
Yeah. Poison.
Altitude matters.
Yeah. Quadlibet asks, K Wode, I bet. Dr. J says the weather satellites were used for other purposes, GPS, emergency transponder, tracking, etc. Mm-hmm. Can they be used to help with extra jobs in case of natural disasters?
I'm not sure what you mean by extra jobs. They are used in case of natural disasters to do the looking for emergency transponders, to suck data out of weather stations on the ground. But they can't really take over for a helicopter. We still need helicopters.
Right. Yamagishi-san asks if I'm going to ever have another movie night on my channel. Maybe. I don't know. We did Armageddon. Nicole and I watched Armageddon together, so that was fun. it caused a lot of like confusion because we weren't actually displaying Armageddon.
Right.
You had to synchronize it with your own copy of Armageddon or the one that was on Netflix. It was a lot of fun. Yeah, I could do it again.
And I noted that Twitch streams Cosmos starting every Thursday. They marathon the whole
I
thing.
know.
And now I want to go through Twitch and see if there's anything else that they marathon on a regular
They
basis.
do, well, I don't know if they're doing it on a regular basis. They did a bunch of stuff though. The painter.
Pollock?
No. Fluffy little clouds, happy little trees.
Oh, curly haired
Yeah.
person,
Internet,
PBS.
remind us.
I
And there was
grew
another
up with
one that
him.
they did as
Yeah.
well.
He always made painting trees look so easy. And if I tried what he did, it was failure.
R. Instro asks, are scientists able to explain why 400 parts per minute, Bob Ross, 400 parts per million are more dangerous than the 1,000 to 25,000 parts per million during the time of the dinosaurs? Why is 400 parts per million such a big deal when back in the dinosaur time it was up to 25,000
I would need to
or
fact check that.
2,500?
Yeah, I don't know.
I can take.
Um,
I mean,
I do.
one, the Earth was cooler in the past, or was receiving less sunlight in the past because the amount of output from the sun was less.
And I don't know if it was the same kind of particles. I don't know what other factors were at play. I don't know. I'm just going to flat out say I have no idea.
But also, they were dinosaurs and gigantic insects, and they didn't care about where the coastlines were.
Reptiles.
Yeah, they were
They were
dinosaurs.
giant
No, they were
reptiles.
dinosaurs and giant insects.
Oh,
right?
okay.
At the
Yeah, I
time,
missed the ant.
at the time, they were just dinosaurs, and there was insects, and there was trees, and they dealt with the changes by dying or evolving into other forms. Here, right, we're not concerned about whether the Earth is going to survive the carbon we're pumping into the atmosphere. We're wrecking Earth as it is right now, the way we
Yeah.
like it, where our crop, like, yeah, you planted a crop, you grow a certain kind of food in a place, and then now that place doesn't grow that kind of food anymore. And that's a problem for human beings. You built your house on your nice little beach, and now your house is 200 feet underwater. That's a problem for human beings. So really, this is the issue: is that we're concerned about what we're doing to the environment because we're making it suck for our modern society, which everybody depends on. The number of human beings that we have that have to eat, that the way we've organized all of our cities. And if we weren't here, life would be fine. They wouldn't care. So
And I just pulled up a graph that goes back 400,000 years. And in the past 400,000 years, which is when mammals have been around um, as a dominant species, we've always had significantly less carbon dioxide than we have right now.
yeah, but there's been lots of
So,
times when there's been way more carbon dioxide. Yeah,
yeah.
and the animals that went extinct because of it were not happy about it, and the animals that evolved out of it were glad to see these new changes. And so we could be one of those animals that goes extinct, and we'd be a little bummed about it. All right, I've got to run, got to see the parents. Thanks everyone for watching this episode of Astronomy Cast. Pamela, we'll see you in 2 weeks.
And any of you who support us on Patreon, patreon.com/astronomycast, thank you. And I'm going to start office hours as soon as I can do the close this window, open that window. So I will see all of you on the other link in just a few minutes.
Awesome. All right, thanks everybody.